Good morning. Good morning to all. Dear students, today we shall discuss about the chemical reactions of phenol. We shall just recall what we studied in last class. In last class, we discussed about the chemical reactions of alcohol and we studied oxidation of alcohols. See, on oxidation, primary alcohol with a mild oxidizing agent, it gives aldehyde. Alcohol oxidized with strong oxidizing agent like acidified potassium permanganate, carboxylic acids are obtained. The mild oxidizing agents are chromic oxide, CrO3, or PCC, pyridinium chlorochromate. See, we wrote reactions also, practice oxidation reactions of alcohol. Again, oxidation reaction with copper, the catalyst copper at 573 Kelvin. Again, primary alcohol is oxidized to aldehyde and secondary alcohol is oxidized to ketone, but tertiary alcohol oxidized to alkene. See, why? In tertiary alcohol, carbon to hydrogen direct bond is not available. So therefore, dehydration takes place, not hydrogenation. In secondary and primary, dehydrogenation takes place. Only hydrogen element removes. But here, a water molecule removes. So that you have to remember. Okay, dear students, today we shall discuss about chemical reactions of phenol. You know the structure of phenol? So this is nothing but phenol. Okay, we shall have a line. So this is phenol. See, phenol. When it is treated with dilute nitric acid, HNO3. So we will get. See, ortho and para substituted product. See, this is nothing but OH and NO2, which is called, see, orthonitrophenol. In ortho group, nitro substitution is done, right? Therefore, it is ortho nitrophenol. And here again para nitrophenol. So this is the one. Para nitrophenol. Are you clear? See, two molecules just to balance this. Again, two we can take. See, when phenol is treated with dilute nitric acid, orthonitrophenol and para-nitrophenols are obtained. See here, orthonitrophenol, as we can find here, in the molecule itself, see O and H, there is a hydrogen bond between oxygen of the nitro group and this hydrogen. And this particular hydrogen bond is called intramolecular hydrogen bond. Due to intramolecular hydrogen bond, so we can easily separate, and this is a steam volatile. It can be easily separated. If you go for para-nitrophenol, we can find an association. Both the molecules can combine, which is less volatile, less volatile and this is more volatile. Are you clear? When phenol is treated with dilute nitric acid, orthonitrophenol and para-nitrophenols are obtained. Orthonitrophenol can be separated by steam distillation and we can find intramolecular hydrogen bond. You studied in first PUC itself. And this is para-nitrophenol where the association takes place and it is less volatile. So we may get one more question. Among orthonitrophenol and para-nitrophenol, which is more volatile, give a reason. So reason is here intramolecular hydrogen bond. We can find here also hydrogen bond, which is intermolecular hydrogen bond, molecule to molecule. We can find, say, this is the limited structure where intramolecular hydrogen bond we can observe. So this is O and this is H and this is N and this is say O and this is another. We can find an hydrogen bond. This is nothing but a hydrogen. In molecule itself, Are you clear? Okay, therefore it is more volatile. Okay. We can find an association. Say this is the reaction when dilute nitric acid reacts with phenol. See, as hydroxyl group, phenol always will get a product in ortho and para position. Are you clear? So OH group is nothing but electron donating group, oxygen atom. So it gives an electron to the benzene ring. Benzene ring is more stable. So therefore, it is difficult to remove OH group. And all these are electrophilic aromatic substitution reaction. Electrophilic aromatic substitution reaction. Okay, we shall continue our study next. That is nothing but with concentrated HNO3. With concentrated HNO3. So phenol reacts with 3 molecules of concentrated HNO3. So we will get. So this is nothing but phenol, OH, and see, one nitro group is introduced here, another nitro group is here, and another nitro group is here. So this is nothing but 1, 2, second position, 3, 4, 5, 6. So therefore it is 2, 4, 6 trinitrophenol. Are you clear? When phenol is treated with concentrated nitric acid, 2,4,6 trinitrophenol is obtained. 2,4,6 trinitrophenol is obtained. What is the name of this compound? 2,4,6 trinitrophenol, which is also called this picric acid. Are you clear? See, it can also be obtained. So OH and phenol, which is nothing but a OH group is attached to benzene ring. When this phenol is treated with concentrated nitric acid, and we will get 2,4,6 trinitrophenol. 2,4,6 trinitrophenol is also called what? It's also called is that picric acid. Are you clear? So it is first layer method. A phenol is sulfonated by using sulfuric acid. So we will get sulfonated phenol. On treating with nitric acid, we can also prepare picric acid. That is an alternate method. Okay, your students say how to remember. When phenol is treated with concentrated nitric acid, 2,4,6 trinitrophenol is obtained, which is called picric acid. Okay, then we shall study, note on the reaction. Next we shall study a reaction with halogen, which is called halogenation of phenol. We shall study halogenation. See, halogenation. Halogenation reaction. When When phenol is treated with bromine. When phenol is treated with bromine in presence of carbon disulfide, solvent carbon disulfide. So we will get again, say this is nothing but phenol and bromine, which is nothing but orthobromophenol, and another one is, say this is parabromophenol. Are you clear? And this is nothing but a major product. This is major product. Are you clear? See, in halogenation takes place in phenol, and solvent like carbon disulfide, it doesn't require an halogen carrier. If you compare halogenation of phenol and benzene, if we compare the phenol and benzene, when phenol is treated with bromine, we will get ortho and parabromophenol. If benzene is there, no. This carbon disulfide, it doesn't work. So we want halogen carrier. As OH group is attached to the benzene ring, where benzene is highly active, therefore it doesn't require a halogen carrier. We can find easily an electrophilic substitution reaction. Are you clear? Okay. So therefore, when bromine reacts with phenol in presence of solvent carbon disulfide, so we will get orthobromophenol and parabromophenol. Among these, which is major product? So parabromophenol is major product. Okay, again, when phenol is treated with bromine water, so when it is treated with bromine water, so again we will get see 2,4,6 tribromophenol. We will get, so this is nothing but phenol, and one bromine is substituted in ortho, another in para, and another in, say, therefore it is called 2,4,6. What is the name of this compound? 2,4,6 tribromophenol. Are you clear? So this is called 2,4,6 tribromophenol. When phenol is treated with bromine water, 2,4,6 tribromophenol is obtained. And these are the two important reactions of halogenation. Are you clear? Are you clear? Note down the reaction, and as soon as completion of the topic, we will send the notes. So this is called bromination. So as 3 molecules, just to take, again we will get 3 HBr is the side product. No need to mention side product. I will repeat again. In halogenation, phenol, when it is treated with bromine in presence of carbon disulfide, ortho and parabromophenol are. When phenol is treated with bromine water, excess of bromine water, so we will get 2,4,6 tribromophenol. That's all. Okay, that is nothing but halogenation of phenol. We completed nitration and as well as halogenation. Then we shall continue our discussion on other reactions. So, named reactions. See, two important named reactions of phenol, which frequently asked in your annual examination. One is coal-based reaction. We shall study coal-based reaction. Coal-based reaction. Are you clear? See, coal-based reaction, what is the theory behind this? When phenol is treated with sodium hydroxide, sodium phenate is obtained. The formed sodium phenate, on treating with a weak electrophile, carbon dioxide, on acidification, it gives salicylic acid. It gives salicylic acid. Phenol is converted to salicylic acid. What is the named reaction? It is coal-base reaction. So, what are the reactants there? Phenol, again sodium hydroxide and carbon dioxide, and also finally you have to acidify. We shall write the reaction. Phenol is converted to salicylic acid. Are you clear? Phenol is converted to acid. See, salicylic acid. Salicylic acid. So this is nothing but phenol. It is phenol. OH. When it is treated with sodium hydroxide. Sodium hydroxide. So we will get sodium phenate. See, sodium phenate. ONA. Again, it is on treating with the carbon dioxide, a weak electrophile, and finally on acidification. So this is the first step, and in the second directly we will get salicylic acid. So this is OH. Again, double bonds are here, and this is nothing but COOH. So it is called salicylic acid or 2-hydroxy benzoic acid. So this is called salicylic acid. Are you clear? What is the name of this compound? Salicylic acid. When phenol is converted to salicylic acid, what are the reagents are used? Sodium hydroxide, a very weak electrophile carbon dioxide, and OH. See, we are going to insert a carbonyl group. That is carboxylic acid, COOH, on ortho position. And particularly, this reaction is called what? Coal-base reaction. This reaction is called coal-base reaction. Are you clear? In coal-base reaction, what is the final product? Final product is salicylic acid. So, what are the reagents are used? See, we are going to use sodium hydroxide, carbon dioxide, and acidification. So this is coal-base reaction, very important reaction for your examination. And next we have to study fourth important reaction, which is called Reimer-Timmerman reaction. MANN, Reimer-Timmerman reaction. See, it is again phenol. When phenol is treated with chloroform, is treated with CHCl3 chloroform in presence of sodium hydroxide. So we will get a derivative of, say we will get ONA, and this is nothing but CHCl2, and adapt is formed, This is nothing but an adapt. See here, it is called benzyl chloride. CH is there. If it is CH2, then it is benzyl. If it is CO, benzol. We studied in first period. And finally, again, it is on reading with NaOH, and as well as on acidification. And this complete is removed, and an oxygen is introduced here, and we will get salicylic. A phenol is converted into salicylic. That particular reaction is called Reimer-Timmerman reaction, and we will get aldehyde. COH and CHO. So this is called salicylic. It's called salicylic. Are you clear? When phenol is treated with chloroform in presence of sodium hydroxide, sodium phenate is obtained, and that is nothing but an intermediate is called an intermediate. So write in simple way. No need to write all the steps. again on treating with sodium hydroxide, and finally on acidification. Finally on acidification, no need to write separately. So we will get phenol and an aldehyde group is introduced. So that is main product. What is Reimer-Timmer reaction? An aldehyde group is introduced there. Are you clear? So that is called, that is an aldehyde group is introduced. Therefore it is called, that is the main aim of Reimer-Timmer reaction. So what is Reimer-Timmer reaction? When phenol is treated with chloroform in presence of sodium hydroxide, say an intermediate is formed. It is again treated with sodium hydroxide and H plus we will get salicylaldehyde. We will get salicylaldehyde. And this particular reaction is called Reimer-Timmer reaction. We studied two named important reactions. What are those? One is Kolbe's reaction, another one is Reimer-Timmer reaction. Are you clear? One is Kolbe's reaction and another one is Reimer-Timmer reaction. Okay, we shall continue. In Kolbe's reaction, phenol is converted into salicylic acid. In Reimer-Timmer reaction, the phenol is converted into salicylaldehyde. That's all. So, what are the reagent used? Or explain Reimer-Timmer reaction. See, phenol on treating with chloroform along with sodium hydroxide and finally on acidification, and aldehyde group is introduced in benzene ring and salicylaldehyde is obtained. That particular reaction is called Reimer-Timmer reaction. Another one, that is Kolbe's reaction. Are you clear? So repeatedly I am going to tell you the Kolbe's reaction and Reimer-Timmer reaction. In Kolbe's reaction, what is the electrolyte used here? The electrophile, particularly electrophile, is a weak electrophile, which is nothing but a carbon dioxide. Okay, so this completes our study of named reactions. Only two important named reactions in phenol. That is one Kolbe's reaction and another one is Reimer-Timmer reaction. Then we shall study next chemical reactions. Reaction with zinc. With zinc. See. So fifth important reaction. When phenol is distilled with phenol is distilled with zinc, we will get, see, directly we will get benzene plus certain. So most important reaction, very simple reaction. You studied in first PU preparation of benzene. When phenol is distilled with zinc dust, we will get benzene. See, an hydroxyl group is completely removed. Oxygen, more electronegative oxygen, which is attached to the sp2 hybridization of the carbon atom of a benzene ring is removed. So this is a special reaction. When phenol is distilled with zinc dust, benzene is obtained. And this reaction is nothing but a reaction with zinc. Okay, then we shall study oxidation reaction. See, oxidation of phenol. See, phenol can be oxidized in the presence of chromic acid, sodium dichromate along with concentrated H2SO4. Benzoquinone is obtained. See, two ketonic group is introduced to a benzene, a special reaction again. That is nothing but oxidation of phenol. See, when phenol is oxidized, in the presence of sodium dichromate Na2Cr2O7, it is acidified, which is nothing but H2SO4. So we will get benzoquinone. See, a special reaction is two ketonic group is attached here, which is called benzoquinone. So we know. Are you clear? Very, very important. How benzophenone is obtained? When phenol is, see, when phenol is oxidized in presence of sodium dichromate, we will get benzophenone. We'll get benzophenone. Very, very important reaction. And here two ketonic groups we can find. So this is one and another. So this is nothing but oxidation of phenol. Are you clear? It is nothing but oxidation of phenol. When phenol is treated with chromic acid, we will get benzophenone. And this particular reaction is nothing but oxidation. See, two oxygen atom is introduced, and it is nothing but a ketonic group. Are you clear? So these are important chemical reactions of phenol. So we studied nitration with the dilute nitric acid and concentrated, and again we studied with the bromine, and again with the bromine water, and then we discussed about coal-base reaction, and we discussed about Reimer-Timmermann reaction, and now we discussed about the reaction with the zinc and reaction with the phenol. So this completes the chemical reactions of phenol. So we shall study some, what are the reactions we studied for the phenol. Okay. So this is nothing but phenol. It is nothing but phenol. OH. Just a rotation in OH. It is nothing but a phenol. Okay. See, phenol when it reacts with the dilute nitric acid. See, dilute nitric acid HNO3. So you will get ortho and para nitrophenol. Orthonitrophenol. See, orthonitrophenol. NO2. And another one is para-nitrophenol. Just you have to study like this. And again, bromination. In bromination also you will get two types. One is bromination with CS2. So you will get ortho-bromophenol. And another one is para-bromophenol. So para-bromophenol. So this is nothing but para-bromophenol. Is it not? Again bromination with bromine water. See, bromine water. What you will get? 2,4,6 tribromo. It is the bromine water. So again we are here, and again here. So this is called 2,4,6 tribromophenol. Are you clear? 2,4,6 tribromophenol is obtained. Again, another important reaction is coal-base reaction. In coal-base reaction, phenol, so you will get salicylic acid. Here OH and COH. So what are the electrophile we are going to use? Here, electrophile is carbon dioxide. Again, in Reimer-Timmermann reaction, so phenol is converted into salicylaldehyde. Aldehyde is introduced. Are you clear? And these are important reactions of phenol. Again, when phenol is distilled with zinc, directly you will get benzene. See, most important reaction. Again, phenol is oxidized on oxidation. So you will get benzophenone. Double bond, and here also double bond, two ketonic group, which is also called phenol. Are you clear? Which is also called phenol. Okay. What are the total chemical reactions of phenol we have here? Say, phenol treated with dilute nitric acid. Again with concentrated nitric acid, you will get picric acid. bromination. See, halogenation of phenol takes place without an halogen carrier due to the presence of OH group 2 directly attached to benzene, which activates the benzene. Again, so therefore, electrophilic aromatic substitution is easier. Again, in the pole-base reaction, which is called salicylic acid, phenol is converted to salicylic acid. In pole-base reaction, what are the reagents used? Carbon dioxide, again NaOH, and finally you have to acidify. That's all. Again, in Reimer-Timmerman reaction, phenol is converted into salicylaldehyde. An aldehyde group is introduced. So, how aldehyde group is introduced? In the presence of sodium hydroxide and chlorophol. And finally, it is acidified. So, we will get an adduct, benzyl chloride. So, phenol is converted into salicylaldehyde. So, repeatedly, you have to write the reaction so that which easily you can remember. Okay? So, after that, we have to study about methanol and ethanol. Methanol, say CH3OH. Methanol can be prepared by, say, carbon monoxide gas when it is treated with hydrogen gas, in the presence of zinc oxide and chromic oxide, nearly 200 to 300 atm pressure, and along with nearly 573 to 673 Kelvin temperature, we will get, see, CO and H2. We will get methanol, CH3OH, which is also called wood spirit. So, we will send you in notes. Methanol, it is poisonous, which can be prepared by drastic conditions. See, it is very difficult to maintain 200 to 300 atm pressure when carbon monoxide gas is compressed to such a high pressure, and in the presence of zinc oxide and chromic oxide as a catalyst, nearly at 573 to 673 Kelvin temperature, this carbon dioxide or hydrogenation by passing hydrogen gas, which can be converted into methanol. Are you clear? Okay, which is a poisonous liquid. Then you have to study again preparation of ethyl alcohol, which is nothing but ethanol spirit. See, which can be obtained by sucrose C12H22O11 in the presence of water. See, in fermentation. So it is nothing but a cane sugar juice, sucrose. See, sucrose on fermentation by enzyme invertase. So we will get C6H12O6 glucose, and also we will get C6H12O6 fructose. Are you clear? We will get two important compounds. What are those? One is glucose and another one is fructose. See, this C6H12O6, which is called glucose. See, again on fermentation by the enzyme zinase, it gets converted into 2C2H5OH, phenol and carbon dioxide gas is liberated. So this is the preparation of ethanol. Okay, so in earlier syllabus it was there from molasses it can be prepared. So it is a very good solvent, so which is used in many purposes in industry. So this is the preparation of ethanol. So ethanol is prepared when sucrose is hydrolyzed in the presence of invertase. We will get glucose or fructose. and one molecule of this glucose in presence of zymase as a enzyme, it gets converted into ethanol. It gets converted into ethanol. Are you clear? So we completed the study of alcohols and phenols. So you have to write what are the uses of ethanol, then methanol you have to write. And we shall continue our study on ethers. Next we have to study about ethers. So we shall study some of the nomenclature of ethers. Okay? You studied now the preparation of methanol and as well as ethanol. Methanol is poisonous. Ethanol is prepared by sucrose. And it is nothing but an enzyme catalyst. Fermentation takes place. Okay. Very easy reaction. Then we shall study about ethers. The last part, ethers. Ethers. Only some basic thing, and one class is required to complete this: alcohol, phenols, and ethers. Now, ethers, say CH3O, CH3. If an alkoxide group is introduced by replacing a hydrogen atom of an hydrocarbon, are called ethers. That's all. See here, CH3OCH3. What's the name of this compound? IUPAC name. Only one carbon atom we can find. Its IUPAC name is methoxy-methane. We discussed this. Whatever is general or common name, it is nothing but dimethyl ether. Dimethyl ether. In the nomenclature of ether, see CH3O, CH2, CH2, CH3. So a longer chain is considered as hydrocarbon. The short chain is named as an alkoxy. Are you clear? So therefore, what is the name of this compound? So it is nothing but methoxy propane. 1, 2, 3. IUPAC name is methoxy. See, methoxy propane. Methoxy propane. Are you clear? What was its IUPAC name? CH3O, CH2, CH2, CH3. It is called methoxypropane. Methoxypropane. Are you clear? Okay, next. So this is, I am going to write another one. See, CH3O, CH2, CH2, again O, CH3. See, only chain is here. 2 carbon atoms are there. Only 2. So therefore it is, see, dimethoxy ethane. Its IUPAC name is methoxyethane. See, particularly in the nomenclature of ethers, students are going to wrong. As the longest chain, we have to take as a hydrocarbon. The short chain, which consists of oxygen, and we will call this as alkoxy or ethoxy, then particularly methoxy. Are you clear? So this is nothing but dimethoxy ethane. Only 2 carbon atom represents the carbon chain. And here oxygen atom, continuous chain will grow. So therefore it is dimethoxy ethane. So this is how we can write IUPAC name of ethers. We studied it, and we shall study some of the chemical reactions of ethers and all other aspects in next class. Another one class is required for the study of alcohols at your own time. Don't do like this. See, already solid state and alcohol phenol notes the half notes, that means about 4 to 6 pages notes are sent in PDF file. So download it and write in your notebook. Again, other part of the notes is shortly sent to you. See, dear students, due to COVID-19, we are going to deliver our syllabus only by online class, maybe extend to 1 or 2 months. So therefore, your sincere work is watch online class and write down the notes, solve some question paper. In coming days, we are going to send you some exercises. Okay? Thank you.